Hello, happy Thursday, and welcome to today's Saratech enablement session. My name is Andrea Hall, and I'm the Customer Relationship Manager at Saratech, and I'll be your host. Presenting today, we have Mark Anderson, who's an applications engineer here at Saratech, and he's going to be talking to you about some new operations in NX12. Our sessions run about 30 minutes each, and they're all recorded and posted to our Saratech YouTube channel. So make sure that you check out the past sessions there. Twice a month, we meet right here just to learn about new tips, tricks, new and old features that'll help you with your everyday tasks. As you can see here on this slide, this is an open forum. So if you have questions or comments during the presentation, you can type them into the questions box over on the right-hand side, and I'll interrupt Mark and just let him know about your comments or questions. And with that, I'm going to pass the baton over to Mark.
Hello, as Andrea said, my name is Mark Anderson. I'm an applications engineer with Saratech, and I'm responsible for the CAM applications, NXCAM, CAM Express, and the newly created CAM Pro for Solid Edge. Today, as Andrea said, we're going to be talking about some of the new operations in NX12 and some of the new options that are available to you in some of these different operations. We're going to be talking about the adaptive roughing operation, the advanced finishing strategies that are new to NX12, the tube machining with guide curve, the turbo machining, and then now we have drafting in CAM. And before we weren't able to connect the CAM module to the CAM side. Now we can go into the CAM side and do all kinds of neat things with work instructions. So first we're going to start off with the adaptive milling. The adaptive milling operation is NX's operation that it's very similar to that of iMachining or volume mill. What it does is it takes and it creates a toolpath that has a very long axial depth of cut with a very shallow radial width of cut. And what that does is it creates a very consistent load on the tool. And it also it saves the tool for resharpening, because our conventional roughing strategies, they were half diameter, depth of cut, 75% width of cut. So it's very shallow, and it didn't create a very good load on the tool. Now that this adaptive roughing, it's our high speed strategy. Excuse me. It gives a smooth flowing tool path. As I said, a consistent tool load. And some of the benefits are it reduces the tool path time up to 60% and the machining time. It's ideal for hard materials, and it can extend your tool life up to 4 times. And these roughing strategies that are this type of adaptive or adaptive roughing, they are going to become the consistent roughing strategy in industry. So if you're using the old style roughing strategies, you're going to very easily be quoted out to where you're not going to be able to compete in the market with these types of strategies. This is the enhanced finishing strategies that are inside of the operations. We have new finishing capabilities that give a consistent step over. And previously in our streamline, going up and down walls, going from steep to non-steep, you would see a deviation in your tool path where it would widen or it would get closer together. And with these different options available to us, it helps us control that, so we can get a very consistent step over and a very consistent surface finish. We also have different options for machining across gaps. So now we don't have to patch them or trim them or create stage modeling to remove them. We have different parameters that will allow us to cut across gaps. The benefits: you can achieve a superior quality of machine surfaces, that you can eliminate the prep work and reduce the rework time that it takes for some of these these strategies. When you have the rough surface finish, now you can reduce that rework and only have to do it 1 time. So we'll talk about the complex part machining with the NXCAM, and you can create these 5-axis operations using the built-in expertise in NXCAM. 2 of those are the tube machining with the guide curve and the turbo milling. Excuse me, I have a slight cold. Some of these operations here, they're very complex, and they give us toolpath that traditionally would take several 20 to 30 different operations to be able to get the same type of toolpath. The tube milling, it's specialized. It's been built for things like manifolds, And even manifolds that have the air disturbance nodules inside that break up the airflow, this operation easily configures and performs to cut that. And we have different options to go from one side or from both sides if your machine tool is capable. It will produce toolpath for ball mills, but it's very uniquely specialized for spherical mills. Currently in NX12, it's more of a finishing strategy. You will have to use your standard 5-axis 3+2 style roughing toolpath to get that cleaned out, but you do have the advanced operation to be able to do that. And it's inside of one operation. You list 3 things: surfaces, all the surfaces you want to cut, what guide curve you want to follow, and then you fill your non-cutting moves and your cutting moves out, and generate the toolpath. That's all you do. And I'll show it better with the turbo milling. I have a very good part that I'm going to be able to show you. So these are efficient roughing and finishing strategies. It's automated tool orientation, the precise control of the cutting parameters, and your benefits are you streamline NC programming, you eliminate errors on the shop floor, you shorten machining time, and you improve machining surface quality, but not to mention do you greatly shorten the programming time. So let's get into the demos. First, we're going to go through the adaptive milling, the adaptive roughing strategy, and it's just in your contour selection. Here is your adaptive milling. In the graph here, it shows a small graph of what it's the point of the operation. Getting into the operation here, you have your same parameters that you're working with, the same things that you fill in, except there's one major: you don't have a cut area in this. And the reasoning is it does a volume to volume roughing. So it takes the finished part compared to the blank in the condition it is, and then it creates toolpath accordingly. It takes the parameters that you've set your tool up with, and then it goes off these parameters. Your step over percentage of tool flat, I have 10%, and I have a constant depth of cut that's 95% of the flute. Excuse me. And everything else is the same. So in an effort not to have to generate this, to see the toolpath, I do want to show you how quickly it does generate this toolpath. This algorithm is very quick. So when I hit generate here, right now it's tracing and it's giving us cut creation and its patterns. And one thing that you need to pay attention to is the types of engagements that it has. Traditionally, we have different cut patterns we can select from, but it's a singular event. We have a way to get into the part with our engagement, and then we have our cut pattern that it's going to go throughout the operation with. With this, it goes between 3 different cut styles. It'll do a spiral circle mill into the part. Then it will do a circle mill or a D-slot trichordal, to where it doesn't come up out of the part. It just rapids our fast feed rates from its exit point to its begin point, and then it creates the feed move, and then it fast feeds to its next approach point. So it greatly improves cutting time, so it doesn't come up in Z and reposition and re-rapid. So the tool stays in cut as much as possible. So you can see down there, it's creating the cut pattern 35, 36 of 100. It's on its second depth, second level. And then when we verify this, for the power that it's in the accuracy of toolpath and the efficient toolpath it's creating, it's a very quick operation that's generating. In comparison to our cavity milling, our traditional cavity milling, it processes out at approximately the same time. So now it's done. So when we verify this, I'll slow it down to 50%, 3D dynamics, so we get material removal. And you see that's the D-slot trichordal. And it's going to take that D-slot trichordal until it has to change. But it's 95% of the flute length. So the full amount of the tool is able to be used. And what you'll have on this toolpath while it's in cut, you'll have a very smooth cut. You're not going to hear different variant in the tool load. You're not going to get chatter in corners. You're getting the full efficiencies and the full benefits of a trichordal cut pattern, but in a adaptive roughing style pattern. So if you were to compare this to something like iMachining or volume mill, you're going to get around the same type of toolpath. It's the same type of strategy and the same type of effect. And as I said, if you're a job shop or even producing your own components, if you're not working with an advanced roughing strategy like this, you're very easily going to be bid out, because you're not going to be able to compare to the traditional half diameter, 75% cut patterns that traditional roughing algorithms give you. So you can see the benefits of this style of roughing pattern. It easily and quickly removes material. And I've cut material with the correct style of end mills up to 70 Rockwell with this cut pattern. The cut load is it's so accurate and so stable that it can easily cut. With the correct tooling, it can cut 70 Rockwell. So I'll speed this up a little bit just so you can see the finished result. And at no time, no matter what type of cut it's doing, is it ever loading the tool up more than any other time. It's all the same load on the tool with this cut pattern.
And for those of you who have joined a little bit later, just remember that you are welcome to ask questions or make comments in the questions box over on the right-hand side of GoToWebinar, and Mark can answer them on the spot.
Okay, so that was the adaptive roughing pattern. Now we'll get into the turbo machinery. So the first thing that we're going to do on the turbo is we're going to create a geometry. And this is just because of our picking ability. So we don't have to pick. There's a lot of different surfaces there that throughout this many operations you would have to pick over and over again. So we're going to create an operation or a geometry so that we only have to pick once. So we specify our hub, we specify our shroud, and there is a rhyme and reason. You have to, whatever blade you select, you have to select the blade to the right for the splitter. So you just have to pay attention to what you're doing. There's your walls, there's your blade blends, and then you have your splitter. So I picked the right splitter to the right of it, and I told it there were 6 instances of this pattern. And then what this is going to do is, yes, there's 6, but to cut on this side of the blade and this side of the blade, when this overlaps, it's going to double up on a surface that it doesn't need to cut twice. It will trim that surface out. And as I said, I don't want to clog up too much time with generating. So I created this geometry just so that in my operation, it's already set for me. So all of my different options are set. The only thing is this, I selected my riser as a check surface so that it didn't cut anything. And it knew that it had to swivel around it. Here are the parameters for that. I just told it I wanted to cut along the axis, distance I want to go over, the tangential extension, the radial extension, the trailing edge is the same as the leading edge, and then a start position, and then different parameters here, just our standard cuts. And when you display this, it'll give you a tool center display. So it's showing you it's cutting to the right side of this blade, down on the opposite side of the splitter. So I'm going to hit cancel here just so that I don't have to regenerate. But these options, they generate fairly quick. So I want to show you the sub finish, because everything is identical. We selected our geometry up here. Everything has been selected because we selected that geometry. We have different drive methods is all that's different between blade rough, blade finish, splitter rough, splitter finish, hub finish, blend finish, blend finish. And all these blend finishes are pretty much a corner cleanup operation that is built into a five-axis operation. So I want to show you the generation time on the most toolpath intense operation. And you got to remember, this is a full 5-axis toolpath. You tell it which axis it's going to rotate and then which axis is going to tilt. And I have that toolpath that quick. Blade finish. This is going to be, I told it that I want it to do a edge, touching on the edge, a swarf toolpath. So it's going to give me a step down style swarf toolpath. This one will take a little longer because of all the motion that has to be done. But when I generate this and I turn the machine tool on, I do have a Trunnion style machine hidden in the background. to have to show it, to have to select the things that I had to select, and the time that I have in this operation to get the type of toolpath that I'm getting from this in a machine simulation is incredible. So I used to program these types of axial impeller blades before out of Hastellay and Inconel with systems like EdgeCam and Hypermill, and they were intensive. They were 30 operations strong. There was very few full 5-axis operations because of the complexity, and NX did a great job on creating an operation that has to have 4 or 5 parameters set, and to give you a full 5-axis toolpath like this is incredible. So I'll go ahead and hit play here. This is machine simulation as well. So this is exactly what's going to be ran on the floor. So that type of toolpath, full 5-axis, one operation, it's pretty incredible. So if you're in the business of making impellers, it's going to be very hard to not have this type of add-on. And you can add this add-on to any 5-axis package, advanced 5-axis bundle, total machining. You just have to have full 5-axis capabilities. But it's incredible to have that. I want to show you the blade finish. That's going to be an incredible operation. Right now it's running through the program to be able to update my IPW. So it's doing a swarf style. And what is not showing you here is that part has been rotated 6 times and this is actually cleaned up. But we have full gouge and collision protection. So we can, and analysis at the end to make sure that all of our surfaces are correct. So it's a very strong, very powerful operation. And as I said, these operations, if you're in the job shop market or even creating your own parts, the advanced roughing, adaptive roughing operation, you're going to have an adaptive roughing strategy, style roughing algorithm to compete in this manufacturing world. And if you're in the market to do impellers, these types of operations, the impeller operations, you're not going to be able to live without them. They're going to be very, very crucial in your business. I could program this impeller in another style. It would take me every bit of 6 to 8 hours. And with these operations in NX, I can get the same part done in 2 hours. So let's get back into the PowerPoint. So 3 takeaways from today's session is, one has to be the ease of use. You saw how quickly I was able to produce those operations and the quickness of generating the toolpath. The built-in technology is amazing. It's the built-in technology that it has to have in the background, the algorithms that have to be running to create those full 5-axis toolpaths are tilt tool axis on steroids. It's just amazing to me that they can do that. And they're very powerful, and I have created toolpath with those and created physical parts, and you can control your surface finish. You can control and weed out chatter by using your percentage factors. And then the power and toolpath generation, just in NX12 alone, they've increased the toolpath generation time by 50%. So between 9 and 10 going 30%, and 10 and 11, 20%, and now we're at 50%. So, they've increased it each version by, 10% or so. And, we're very quick for the types of operations that we're creating toolpath for. So the next session is FEMAP Q&A with FEMAP developers, Thursday, February 2nd. And if you would like any information on that, you can email Andrea Hall at ahall@saratech.com to submit any questions. And if you're ready to take it to the next level, Saratech, we provide a lot of engineering services. We can address any of your demands for advanced engineering capabilities, contract programming, additive manufacturing. We have our own printers. We also sell printers, Markforged, HP, Big Rep, Union Tech. So we have a lot of capabilities at Saratech. We're, a complete service from modeling to FEA analysis to programming to printing. We have it all in-house. Thank you for attending. If you have any questions, I'd be happy to answer them.
Great job. Thank you so much, Mark. Yeah, make sure that you follow us on all of our social media outlets, especially YouTube. If you subscribe to our YouTube channel, you will see all of our sessions, anything that we post on YouTube. We have longer sessions like today's, and we also have some very short videos that we post that seem to be really popular and really helpful with all of our customers and prospects. We will be sending out the recording to today's session, so be on the lookout for that. And again, we hope to see you at the next session in February and hope you all have a wonderful day. Thank you.